Better numbers on K through 12 STEM student production. K through 12 means kindergarten through 12th grade in the United States. STEM means science, technology, engineering, and mathematics. It's a common acronym in various subjects, education, public policy, again in the United States. It became fairly popular about 10, 15 years ago. This is a follow-up I'm doing to a previous article and video that I posted. Mainly what I'm going to do is go through the numbers on AP Calculus from the College Board all the way back to 1997. So that's an additional 5 years of data compared to my earlier article. And this is the students who take and pass AP Calculus exams in the United States. And so calculus is something which is taken by nearly all really serious STEM students, either at the high school level or in college. It's generally considered a college level course. So it's a very good marker for the good qualified STEM students produced, in this case at the K through 12, the high school level. The reason that I'm going into this is to give some actual numbers to rebut very common claims of a desperate crisis in the production of STEM students, especially at the K through 12 level. It's something I've written about and spoken about many times in the past, but I wanted to go down and drill into the actual numbers of why these claims are either greatly exaggerated, that's the best case, or simply disingenuous. I believe many of them are disingenuous, but that's my personal opinion. So this is a plot showing the data and a model of exponential growth in these numbers. So these are students who take and pass one of the 2 AP Calculus exams in the United States. College Board has data on it back to 1997. The tests have actually been given way much further back. So I extrapolate back to make estimates of how many students have actually taken and passed these exams since 1970. So that would be basically most of the people who are still in the science, technology, engineering, and mathematics labor force. The blue squares are the actual data, the numbers from the College Board, and the green line is the model fit, which assumes kind of an exponential growth. It turns out that, in fact, since 1997, with minor fluctuations, the number of students who take and pass these exams each year has grown by almost 6%. It's 5.9% according to the model fit here. So briefly, a little bit more about these tests. So they are given by the College Board, which is an organization in the United States that produces a lot of the standardized tests used in our educational system, the SAT, the Scholastic Aptitude Test. I focused on calculus because it's basically people who take STEM fields, whether you're in physics or chemistry or computer science. If you're really serious about it, you should take calculus. It is either good to know or essential and required for almost any really tough STEM field, quantitative, logical field. And so the BC exam, which is the harder exam, there are 2 exams. There's the AB exam and the BC exam. And the BC exam is more advanced. It's pretty close to, here's what they say about it. The AP Calculus AB is roughly equivalent to a first semester college calculus course devoted to topics in differential and integral calculus. So about a half a year. AP Calculus BC is roughly equivalent to both first and second semester college calculus courses. It extends the content learned in AB to different types of equations and introduces the topic of sequences and series. So BC Calculus is roughly equivalent to a first year full calculus course at a top school. And this is a standardized test. It's the same wherever you take it. So you don't have to complain about questions about how good is the calculus teaching at this high school or that. The point of these tests is to evaluate the students independent of where they go, whether they go to a very humble school somewhere in the rural United States, for example, or whether they go to these big name schools like the Bronx High School of Science or Stuyvesant in New York City, for example, very famous schools that are very competitive to get into and that focus on very advanced topics by high school standards, or science programs and math programs at very competitive private schools or what have you. So what do these numbers show? Again, they show a dramatic increase. I was able to decipher these numbers from the College Board website all the way back to 1997, so that's 21 years. This is the actual numbers here that I pulled out. The earlier numbers I only had back to 2002. There's a difference in format in the reports from 1997 to 2001. Made it hard to figure out what the actual numbers were. So this is a follow-up where I get the actual numbers all the way back to 1997. It's very likely that the College Board has numbers going all the way back to the earliest AP tests, but I don't have those. So I use a model to estimate what the number of people who actually passed these exams years ago. So some useful numbers. As a point of reference, the Bureau of Labor Statistics in 2016 estimated about 6.9 million employed scientists and engineers. So keep in mind this is in a huge labor force of over 100 million people who work full time. There are 320 million people total in the US. About 60% of those are considered in the labor force. So scientists and engineers STEM jobs, and that includes programmers, computer scientists, and software engineers, are actually a tiny fraction of our labor force, probably no more than about 5% at most. It depends a little on what you define as science, technology, and engineering. But these are a small percentage of our workforce, and they tend to be top students, at least as measured by SAT scores, other measures like that. And in fact, they appear to correspond pretty closely to the people who take calculus. So according to my model, since 1970, about 4.8 million people have taken and passed either the AB or the BC calculus exam. So that's not quite everybody, but keep in mind a lot of schools don't give calculus. A lot of people don't take calculus for various reasons, aren't maybe even interested in STEM subjects in high school. So you need to tack on people who do it in college. That's hard to get good numbers for. There aren't standardized tests to use. The standardized tests are for going to graduate school, but most people don't actually go to graduate school who become STEM workers. The actual total that we know took and passed AP Calculus from 1997 to 2016, that's 21 years, are 3.5 million. About 2 million of those took the the AB Calculus exam, the one that corresponds to the first semester of calculus at a college level, and about 1.5 million took the BC exam. And keep in mind that's a full year course. That's 2 semesters. I can say from personal experience taking the BC Calculus program that's fully equivalent. It was fully equivalent to the first year calculus course at Caltech. Caltech didn't believe that, but that was true. Anyways, just the point is it's a serious exam. Calculus is a demanding course. It's difficult to learn. It requires good logical and quantitative skills. People who take it and pass it at a high school level are performing at a very high level. They're very good students, and they are people who can certainly do computer programming. I would also point out, and this is an issue because a lot is being made the last few years about how few students take AP Computer Science. Calculus is actually a more challenging course than computer science. It's actually more of a feather in your cap, or it should be considered more of a feather in your cap. And secondly, today, computers are widely available to students. I'm of an older generation when it was actually hard in high schools to get access to computers. Today, you can buy a new computer for a few $100s. You can get used ones for $50 or even for free from friends, family, whatever, flea sales, whatever. You can certainly get free software. Almost any computer programming language, Python, which is very popular, which I use and is used for this model, is freely available. You just download it from the internet. You go to a Starbucks or someplace with free Wi-Fi, and you can get tons of free software. You don't have to have a state-of-the-art best computer to learn computer science. The point is that the vast majority of these students who are taking and passing AP Calculus today have access to computers, have good high school level computer skills. They're playing around with computers at a level that was impossible or very difficult to do 30, 40 years ago. That's important to keep in mind. These students are computer literate with probably rare exceptions. We can estimate, extrapolating this almost 6% growth rate, that there will be over 4 million students, K through 12 students, who take and pass AP Calculus between 2016 and 2026, about the next 10 years. This is actually way beyond the numbers of alleged purported shortages that are supposed to occur in the next 10 years. So there's, at this point, very likely an overproduction of STEM students at this very high level in the United States. That does not include people coming in through these guest worker programs, the H-1B visa, the L-1 visa, OPT, etc. That's on top of these students in the United States who are graduating with AP Calculus under their belt at the K through 12 level, at high school students. There's a very rapid growth taking place, and has been since 1997, in the number of students taking and passing. It's much, much larger. So the annual growth rate is almost 6%. It's been pretty constant. It fluctuates a little bit, but it's been pretty constant since 1997, and it's far higher than the U.S. population growth rate. So there are lots of students interested in STEM subjects. Contrary to a lot of what you hear, there's a lot of students taking these courses, and they're taking and passing demanding courses at the K through 12 level in high school. So these are not even in college yet. So there's many more students who don't get into it or don't take calculus until they're at the college level. So this means that there's very likely nothing like a shortage. There may actually, in a way, be overproduction of people. There may well be a glut forming in the next 10 years of people with these skills relative to the actual number of jobs. And so, for example, the Bureau of Labor Statistics is predicting about 800,000 actual new jobs for STEM workers in the next 10 years, in this 2016 to 2026 time period. Now, they also predict that about 1.5 million people will retire or die or whatever, so that pushes you up to maybe 2.4 million total, maybe new jobs, counting people who have retired as new jobs. It's still way less than 4 million, and it's actually less than the 2.8 million students you would get if you just extrapolate the 280,000 people who took and passed the AP Calculus exams in 2016 over a 10-year period of time. No growth, not even population growth, just constant. You're going to have more people than the Bureau of Labor Statistics is predicting new jobs would appear, actually. Now, there's some fudging in the Bureau of Labor Statistics. You can read my earlier articles about something called an occupational transfer. But the bottom line is there's a lot of STEM students. There's probably more than enough just produced in the United States, never mind all these immigrants and guest worker programs, to actually meet the need, the current need for these type of workers. Just looking at these numbers, it's quite dramatic. And yet you very rarely hear this. What you often hear are about averages in math performance or science performance. So these are average SAT scores, have kind of fluctuated and never really gone up very much or down in the United States over the last 50, 60 years. Actually, verbal scores went down for a while, and the scores were rejiggered, so it makes it hard to make adequate comparisons. The point is, the average performance doesn't show this. You don't actually see this dramatic exponential increase in math students and math performance. The reason for this is averages are misleading. The students who take science and engineering jobs are top students. They're the top 5 or 10% of students in the United States. And so those top students are getting better and better. As you can see, they are taking AP Calculus and passing as never before. And this has been going on for over 20 years. They're not the average students. The average is highly misleading. In addition to SAT scores, which have the averages have stayed fairly constant, you'll often see comparisons of average scores on so-called international tests. This is PISA, the Program for International Student Assessment from the Organization for Economic Cooperation and Development. It's mostly a European organization, but it's international. And they try to compare the performance of students in the US and Finland and France and China and all over the world. And this is one from another international cooperation organization, the Trends in International Mathematics and Science Study. Again, this tries to compare students at the 4th and 8th grade, not the high school level, remember, between the US and other countries. And our average performance is kind of average. So you'll often hear about some other countries whose scores, their average scores, beat out the Americans. So for example, Finland does, Korea does, Hong Kong does, Singapore does, and China, again, there's an issue here because not everybody in China actually takes these. It's actually people in coastal cities that are elite areas like Shanghai. But the point, of course, is averages are highly misleading. The average performance on these tests tells you little about the top students who actually who work in science and engineering. They're the top math students, the people who score the highest on SATs, the people who take and pass AP Calculus, which is a fraction, a fairly small fraction. And the U.S. has about 4 million people who graduate from high school each year, but we only have about 280,000 people each year who take and pass the AP Calculus exams. So these are the top math science students. They're generally top students. They often will turn out to be somewhat weaker in verbal scores and English language skills, sometimes dramatically so in a few cases, but generally they're also good English verbal skills students as well. They're just not, they're stronger still in the math and science areas. So this means that there's a lot of STEM students out there who are highly qualified. I mean, taking calculus is a difficult thing to do and passing it. And these averages simply don't show this. And that's one of the issues in these many claims which try to say that the average tells you something about the quality of math teaching in the United States and students. But math and science is a minority activity. Only maybe 5 or 10% of students seem to be really interested in it and do it. And they're not representative of the general population. They're not the average students at all. In fact, when you look at them, they have quite a different ethnic compositions, gender composition. They differ in many, many ways from average or typical students in the US or any other country as far as I can tell. So that going into like the differences and maybe why they are is far beyond the scope of what I'm talking about here. I just want to make it clear that there is huge production of STEM students who are highly qualified in the United States. These are our top students, or among our top students. That obviously doesn't include, say, someone who does English literature or becomes a lawyer. There are people who are very good students who may not show up in these numbers, but we're concerned about the ones who will go and work and do computer science, software engineering, physics, machine learning, whatever happens to be hot. And they are numerous, and they're being produced in very large numbers. In fact, it's likely that far more will be produced in the next 10 years than there are actually jobs based on these projections, based on this 6% growth rate. And this does not include guest workers and immigrants who are being piled on top of these people produced here at home in the United States. So the upshot for you, if you're thinking about a STEM career, or if you're a parent, you're concerned about your kids, or if you're a teacher and you're concerned about teaching people, is that these are very competitive fields. There's a lot of qualified people out there competing for these jobs, in addition to a large numbers of people being brought in from other countries in the United States. So a lot of people are brought in from the Far East, from China, from Chinese-speaking populations in the Far East, from India, Pakistan, etc. Now these are the elite, top, highly educated students in these countries. Again, we're talking about the top students, not the average students. There's widespread illiteracy in India, for example, but we're getting the top students who are actually usually able to speak English fairly well. It may even be their first language. Some people in India speak English as actually their first language. That's the elite that we're getting. We're getting the people from the so-called upper castes in India mostly, who are highly educated and anywhere from what we would consider middle class to extremely wealthy. And something similar is going on with Asian countries like China, Hong Kong, Singapore. So this is something to think about. In saying this, I'm not arguing that people shouldn't learn math or statistics or STEM subjects or understand basic physics. That's science and math literacy, and that's something that's very important and growing more important as our world becomes more technical. And indeed, that's probably part of the reason for this exponential growth in calculus students, for example. But the point is that there's this difference between understanding math and science and being able to actually pursue a career in it. And as you can see from these numbers, we're producing huge numbers of highly qualified students, even at the K-12 level. And these students are taking and passing college level courses in calculus, which is a demanding, difficult course. So anyone who's considering going into STEM fields needs to keep this in mind, that there are only a few million jobs actually in the United States or in the world. It's larger, obviously, you integrate over the entire world, that are truly these things. And that's true even of computer science and software engineering, which are the largest STEM categories. Probably 3 to 4 million of the 6.9 million STEM jobs that the Bureau of Labor Statistics is talking about, those are actually some kind of computer programming, etc. job. Those jobs are not numerous, and the competition for them is these top students from around the world who have pass AP calculus or may have taken first year calculus as a high school kid basically and done very well. So that's what's out there. That's what you're competing against if you're trying to do this. When you hear companies talking about shortages, they are talking about something that's rather mysterious. There are huge numbers of these highly qualified students in the United States, as these numbers show. They're being extremely picky. That's the most generous interpretation. When a Google or an Apple or Bill Gates at Microsoft or somebody like that is talking about a shortage, they are complaining about the quality of Caltech graduates, MIT graduates. They don't even bother to interview qualified people with degrees at these top schools sometimes, and they don't hire them. They're being extremely picky. It has nothing to do with your everyday experience. It has nothing to do with the job prospects of someone who maybe isn't at that level. They are being extremely picky, and it's extremely important to understand whether they're doing it consciously and deliberately and what they're actually doing. We can't read their minds, but there's no question they're being extremely picky. And when they're whining about the poor quality of American education, they're actually whining about the students coming out of Bronx High School of Science or Stuyvesant. They're saying, well, we're Microsoft or we're Apple or we're Google and we walk on water, and this kid who was, class valedictorian or something is just not up to our superhuman standards. That's what they're complaining about. It tells you very little about your job prospects if you pursue a science or engineering degree, not just at like a mid-level college or you were your class valedictorian in somewhere in Kentucky or someplace. It's not just that. They're talking about they're not happy with people who come out of very top schools. I know many people with degrees from top Ivy League schools, and it's not that easy for them to get these STEM jobs, even in at these high-tech companies, even though by any reasonable definition they're highly qualified. So it's very important to understand this extreme pickiness, whatever causes it and however sincere it is, when these people are talking about an alleged shortage. They are turning up their nose at these people who are passing AP Calculus. They are turning up their nose at people who score perfectly and get fives on the BC Calculus exam in high school. They're turning up their nose at that kid that you were frustrated with in high school who was the class valedictorian who just seemed to be able to do everything so easily. Those people are not at the level these companies claim to be seeking. Now, that may be disingenuous in various ways, but that's on the surface what they're talking about. So it's very, very important to remember these numbers and realize they're huge numbers of people who are learning STEM subjects in high school who are very highly qualified out there. Several million easily. There will probably be 4 or 5 million produced in the U.S. alone in the next 10 years, in addition to people coming in through immigration and through these guest worker programs like the H-1B visa, the OPT visa, L-1. There's several. It's really confusing. So in conclusion, what we have here are better numbers on the K-12 STEM student production in the U.S. going all the way back to 1997 from the College Board, a reliable source. They show at least 3.5 million people took and passed AB or BC Calculus, the Advanced Placement Calculus exams from 1997 through 2016. That's over half the number of people working in science and engineering fields. If you extrapolate backwards, you get something like 5 million, 4.8 million people who took and passed AP Calculus. Furthermore, we know there's a substantial number of people who don't take calculus and don't get into STEM fields or don't get very far into them at the K through 12 level. They take it in college or even some other way. Few are self-taught, but most take it in college. They get calculus in college. They get these degrees in college. Those are harder to measure because there isn't something comparable to the AP Calculus exam that you take at the end of college. There isn't like a standardized nationwide science and engineering exam that everybody takes, like a bar exam or something at the end of their college degree, that allows us to really have a clear picture of the number of qualified people. But it's undoubtedly substantial, and it's undoubtedly larger than the number of students who are taking and passing AP Calculus nationwide. So if you like the video, please click like, give me your comments. I'm very busy with my business. I will try to respond to emails or comments. I can't guarantee that I can do it. And that concludes this video commentary on my article, Better Numbers on K through 12 STEM Student Production.